Hello everyone, have a good evening. I am Eliseu, but you can call me Eli. I'm a bit nervous, this is my first talk, but let's move on. I'm here to talk to you about managing side effects with redux-saga. I'm a developer at productreview.com.au, the biggest consumer opinion website in Australia. We are hiring, by the way. So, after working on this project for a bit more than a year, scaling it up to 4 different front-end applications, 1,600 files, we had to find a way to reorganize our code. And this is where redux-saga comes in. But first, we need to talk about what are side effects. By the way, who has used generators here, JavaScript generators? That's cool. Have you guys ever used any other side effects management library, like Redux Loop, Observables? All right, thank you. So basically, side effects happen when your function or when your application reads from or writes to the external world or something outside its scope. As an example, we can see here a normal JavaScript function. It gets an argument from the outside, from a caller function. It mutates it. The first line is already considered a side effect. The console log is also considered a side effect because it's going to write maybe to your terminal or whatever. And then we do a network call. Any I/O operation, by the way, is considered a side effect. And then we mutate a DOM node. We return a React component with some random number inside. So in this last line, it means that every time you run your code, it's going to produce a different output or have an observable effect on the external world. This is a common example of how side effect is managed in React applications, especially with Redux, of course. So here we have a basic login form component. Whenever it's submitted, we get its values, and we dispatch a login start action. Then we do a network call. If it returns successfully, we redirect the user to the dashboard. Otherwise, we display an error. Very basic. We got a few problems here. First one is testing. In order to test this component, this workflow, you will need to mock your API. You would also need to mock your dispatch function. So it's not really easy to do that. Let's see how we can improve that. Then some guys came up with Redux Func. So you basically abstracted it away. You moved this logic to the action creator. So it becomes more reusable, easier to understand. You remove a lot of clutter from your components. So it's the same workflow, but again, you still have issues to test it. Another thing is concurrency control. Like if your user clicks again on the submit button and you want to cancel the previously running request, it would be pretty hard to do that here. If you wanted to log all these side effects, it would also be hard. By comparison, this is a normal action creator in Redux. So by introducing Redux Func, besides all these problems that I mentioned, you also have an inconsistent return type. So sometimes you return a function, sometimes you return an object. This doesn't look cool. So what do we need? What do we want to make this code better? Sorry. What if we wanted to react to multiple events or a sequence of them? What if we wanted to log all these side effects? What if we wanted to cancel the previous request or retry it in case of a network fail? What if we wanted to test it without mocking? So we already do that with shallow rendering in React. So why not do that with side effects as well? And a couple of other issues when you start scaling it up. You want to send an event to Google Analytics, you want to show a notification to the user, you want to refresh the session token every X time. So in order to scale it up, you would need to call these other workflows from this action creator. How do we solve that? So there are a bunch of libraries out there trying to solve these issues. But one that worked really well for us was redux-saga. I'm not saying that's the only one that works well, but it's pretty well tested. It has a very nice community, very active. So what do we need in this library? We would need modularity, easy testing and reusability, which are all goals of separation of concerns, and also a powerful community. And the redux-saga was created in November 2015 by Yassine Elouafi, and by now it has also almost 7,000 stars. It's the most popular side effects management for JavaScript applications. They have a lot of contributors. But first, before dive into it, we need to understand what generators are. So this is a basic generator function. It's marked with the star symbol there. So what a generator function does is it has the ability to return multiple times, to return a value multiple times. And you can also have a two-way communication with this function. I'm going to show how it works. So we have there the same generator. It gets an argument. Whenever we call this function, it doesn't immediately execute the code inside it. Instead, it returns this iterator object with the next method, and we control the execution from the outside. Let's see how it works. First of all, we just start with an empty value, iterator.next. It's going to jump to the first yield statement. It's going to evaluate whatever expression is on the right side. In this case, just returns 1. And here on the outside, here on the outside, we would have an object with a value and whether this generator is finished or not. Next call stops at the yield statement again, returns 2. Next call, it's going to evaluate this dynamic expression for us. There is an important detail here. So instead of evaluating the whole line, it just evaluates what's on the right side of the yield statement first. And then on the next call, the value, whatever value returned that we pass on, is going to be assigned to double. So at this stage, we are only evaluating the yield. And then, in this case, because we know how the generator was implemented, we can get the whatever value this third call returned and pass on. So the value marked with brown here, highlighted with brown, is going to be assigned to your double variable. So the generator does not do that automatically for us. Fine, so finally, we get our final value, return double, and our generator is finished. Let's move on. So this is the same login workflow built with redux-saga. The most important thing here is that we inverted the dependency. So instead of the action creator doing the workflow for us, we have something like a daemon in your application that's running forever and is listening to these actions. The rest is kind of similar. The take, you see the take call there, put and call, they all come from the redux-saga library. But yield put would basically dispatch an action back to our redux. Take would basically listen for it. Call is used when you want to execute external functions. I'm going to show you why this is important, especially for testing. Yeah, pretty basic. So this saga is initiated together with your application. So when your application starts, we pass to redux-saga a set of initial workflows, daemons. Don't worry about this while true. As we've seen, your saga will be blocked at the yield statements. An external agent here will take care of controlling this workflow. Let's talk about the effects. So redux-saga has some built-in effects. One of the most important ones is take. It will block the execution there until this action is dispatched. It's called a blocking effect. There are also some other non-blocking effects. This one, for example, will dispatch and immediately jump to the next yield statement. And also call. So an important take here is that API.logging was not actually called. The redux-saga will take care of calling this API for us. That means we won't need to test this API when testing. We won't need to mock it. Let's see how all these components are integrated with each other in a real application. So when it first starts, we have our connected components rendered. We have our Redux store set up. We pass redux-saga as a middleware, just like redux-func. So it will be able to know when actions were dispatched, dispatch actions back, and also get this state. So in this case, we pass some initial sagas for it: authentication module, analytics, notifications. It can also connect to web sockets, for example. We could have a music player on it. But let's focus on the authentication saga for now. First of all, we have the take effect. The coordinator will execute this saga for us, and we'll know, oh, the first effect was a take one. It's going to block until it receives this action. So this coordinator here, which is redux-saga, will take care of scheduling for us. Then, after a while, an user on your website submits the form. So the login action is dispatched with the user credentials. It goes first into Redux store. It may or may not change your state. And then our coordinator is notified. Coordinator will then call saga.next with our action, which has type and payload. So here's the big deal with generators. It may also tell other sagas that are listening to the action as well. So they are all running concurrently to each other. Non-blocking, super cool. Then we dispatch a login start action. It executes immediately, does the Redux flow, changes your state, and saga.next is called. Here we are calling our API. Our API.logging returns a promise. So in this case, it's a blocking action. Our coordinator is notified again. Coordinator will actually call API.logging with our arguments. And then when it finishes, we get the response back. Again, login success is dispatched. Our state is changed. And then finally, we redirect the user to the home page or a dashboard. And we can also notify the user. It could be on a separate saga, by the way. And then we get back to the beginning because of our while true wrapping our code. So let's see how it works in practice. Oops. So yeah, what we're going to build here is this simple login form, and when we successfully log in, we're going to be redirected to a dashboard. This is very similar to the slide I showed you before. This is basically a daemon. Think of it as daemons that run in our operational system, your clock sync, keyboard shortcuts. These are things that are always running and listening to events. What's listening to here is our login action. It's going to be dispatched with the user credentials after we click on submit here. After that, it's going to dispatch a login start. Let's see. Blah, blah. Yeah, invalid credentials. So let's see how easy it is to debug it. Let's focus on the watch login saga. So here we can see that first our saga was listening to this action, and then put login start was dispatched. Our API was called with these arguments in here. We can check the response. Oh, fine, that's good. Unauthorized. And then it dispatched a login error with whatever came from the response. And then we get back to the beginning. Now let's use the proper credentials. And make it bigger. Yeah. So here, the same flow again. Almost the same flow. First, login start. Proper user and password. Login was successful. Let's see what we got here. Yeah, our user looks correct. And then we are redirected to the dashboard. In this dashboard, we can see here this sidebar. After we log in successfully, this new saga is instantiated. So they don't necessarily need to be started together with your application. They can be dynamically created. Let's see how it happens. So another cool thing from sagas is that it's easy to communicate between your application modules. In this case, we have authentication and notification talking. First, we select if the user is logged in. This is for the initial page load. And if it's true, we fork a new saga. This fork here will instantiate this new saga and will continue the execution directly. That means it's not going to block this code. It will run concurrently to the parent. Let's see what it does. It just calls our API, just like login, and when it returns, we dispatch add items so that we can show them here on the sidebar. After that, we have another daemon. This is going to listen to the login success action, and after that, it's going to fork another saga called periodically check for new notifications. This other saga, an important thing here is that you will fork this new saga and immediately jumps to the next yield. And this is running concurrently. This is already running. So every 5 seconds, we call the same initial saga here to fetch our new notifications. What else do we have here? We can do things like user activity tracking. So let's pretend the user jumps into this page and we want to detect whether the user actually read our article. We can have a logic like, the user got into this page and then clicked read more and then jumped to the bottom of the page, and we wait 5 seconds and only then we dispatch our analytics event. We can do complex things like that. What else? We can have timers running concurrently to each other. Let me show you how it looks in the redux inspector. Oops. Stop, commit. Let's start our time array. Is running. See the add items here from the dashboard. We should actually have canceled these other saga when we move out of the dashboard. Cool. Reset. So another important thing. Let's see how we can test this authentication saga. You see how easy it is. So it should successfully log in. We create our mock credentials, our mock user, and we call our generator here. Again, this is going to return an iterator instead of immediately executing our code. And we are just going to compare whatever the yield statement evaluated here to the same thing. So we do a equal. These effects here are usually objects like that. And we just do a check. If it actually return that. Next value. Again, next, we pass our logging action here. We pass it back to the generator with our credentials, and we checked if the next yield statement returned a put, an action dispatch, and then we go on and on and on. Here, as you can see, we didn't need to mock client.post that we do the HTTP request. We just check if the redux-saga coordinator will eventually execute this code. We don't need to worry about it. And then, because we passed proper credentials, it will return login success, and then redirect to the dashboard. So again, none of these effects were executed. These are just representations of what should happen. This reminds me of the declarative model in React. So the render method, instead of mutating DOM components, it will just return a representation of what should be rendered at the end, and another library, React DOM, will take care of the side effects. So let's go back. I'd like to explain in more detail how these forks work. Maybe you were a bit confused. So when our application started, what happened? Okay.
While you're working on that, I was just wondering, redux-saga seems to rely almost entirely on using generators. Is there any way to refactor this so that it uses the possibly upcoming async await syntax?
No, because generators has this feature of communicating from both sides. So with async await, your code would also look a bit synchronous, just like generators, but you wouldn't have this power. So when our application starts, we fork 3 different sagas. They run concurrently to each other, independently. But let's focus on the notifications saga. When it receives a login success action, it forks these new periodic checks, and every 5 seconds it forks this new one to actually fetch our data. If the user logs out, we can cancel these tasks. So when you cancel a periodic checks, it's gonna also cancel all its children, all the sagas that were forked by it, all the way down. If an error is thrown by fetch, it will bubble up. just like in normal synchronous code. So what's next for redux-saga? The monitoring and debugging tools are not yet very polished, but they are already usable, as you could see. Integration testing has also room for improvement, but it's working as well. There is a lot of discussion happening in the repository. You can take a look. And I've also got a challenge for you. This guy, Derek, created a repository with some components, a search component. So what you have to do is control the flow. So when the user is typing, you do the HTTP request. If the request was still running, you cancel it. It's pretty cool. Some clarifications before we jump to the questions. Redux-saga might be overkill for your application, so make sure to evaluate beforehand, and you might stick to Redux func just fine, but if you need to scale it up, I would recommend going for it. And there are some discussions about the confusion between the original Saga definition and what redux-saga is doing. If you want to talk about it later, I would be happy to. So, have you got any questions?
When you do a fork, I presume it's asking you instance of the generate function each time. Is there a way to track them, like the IDs? Can you have to maintain a reference to them? How does that work?
Yeah, so redux-saga will take care of scheduling for us. You'll make sure that the action, whatever action the sagas are listening to, they will arrive there. So you don't have to worry about it.
But what if you want to cancel it? Let's say I want to trigger cancellation option or whatever.
So when you use this fork effect, you get back a task object. It has a unique ID. And in the case of notifications, so here we are holding a reference to the periodic checks saga. So whenever logout happens, we can just use another effect that is cancel, and then pass this task object as argument. And then, yes?
If we want to learn a little bit more about generators before delving into using redux-saga in a project, would you recommend any particular tutorial or literature? I know it's part of the ES spec, but it's relatively new. So.
You can probably find good tutorials on MDN, Mozilla Docs. And yeah, I'm sure you find a lot of stuff on YouTube. You can also look at Python code. They use a lot of generators. So, yeah. And by the way, nowadays we would usually need to have a transpiler like Babel in order to use generators, because not every browser supports it. Just a note. Yes?
So, what is the typical way of communicating across these sagas? So, let's say if there are independent sagas on the parent child sagas.
I'm sorry?
How do you typically communicate across the sagas? So, let's say you have different sagas. Let's say you have notification saga, you have login saga. Which are totally different. They are not being forked from the same parent.
Uh-huh. Yeah, so they don't hold a reference to each other, so they run completely independently. So yeah, the way you would communicate between each other is via Redux actions.
There's something called channels.
Yeah, so channels are also another feature of sagas, which are used to communicate to publish-subscribe APIs, something like WebSockets. So you have on message. So generators cannot work with these APIs, so they use these event channels feature to.
Would you recommend that? Or?
Yes, totally. We use that a lot at Product Review all the time. By the way, that's a good question. I'd like to show you an example of channels. So here, we built this uploader a few days ago, and it's totally based on redux-sagas. Yeah. Let's get a big image. Oh, sorry. So hopefully our network is slow.
May not work at all.
Let's slow it down. So here, when we, oops, what? Because it's closed. Good, let's try again. So yeah, here, as you could see, this progress bar running. Let's try again. Yeah. So we do a request with a library like super agent, and the request object has a method that you can listen to the progress of the request. So in order to listen to these events, to these progress events, we need to use channels. So it's basically a way to communicate with stuff other than generators, because generators can only communicate with generators. Yeah. Any other questions? Yes?
Can it be used in React Native?
No, we didn't try it with React Native, but I'm sure it would work just fine. Just make sure you transpile it. It'll be fine.
It can.
Cool, so thank you very much. I